The crossing gates drop, the bell starts up, and the first locomotive slides past exactly the way you expect it to, nose forward, headlight burning a hole through the afternoon, the engineer's elbow resting in an open window. Then the second one goes by, and it is backwards. Not damaged, not being towed, not shut down and hitching a ride. It is running, working, pulling its share, and it is doing all of that while facing the wrong way. Its rear end bolted up against the rear end of the machine ahead of it, so the two of them stare off in opposite directions like a pair of animals that have agreed never to look at the same thing again. Most people who notice this assume it is a mistake, or laziness, or some quirk of whoever assembled the train that morning. It is none of those. That arrangement is deliberate. It is planned days in advance, and the reason for it has almost nothing to do with the locomotive itself. It has to do with something the railroads dug out of the ground and threw away more than half a century ago. To understand why two machines in the same train face opposite directions, you have to understand three things in order. What actually makes a locomotive able to run either way, what railroads used to do instead, and what happened to all the equipment that made the old method possible. But before any of that, we should clear away the wrong answers, because there are three of them and they are all remarkably persistent. The first is the tug-of-war theory, the idea that a backwards locomotive is somehow pulling in the opposite direction, or that the arrangement lets the train be pulled either way at once. This is not how couplers work. Every locomotive in that group is bolted into the same steel chain, and every one of them is shoving in the same direction at the same moment. A unit facing backwards is not fighting the train. It is contributing every ounce of tractive effort it has in the direction the train is already moving, exactly like the one in front of it. The second wrong answer is that the reversed unit is dead. Sometimes that is true. Railroads move failed or repositioned locomotives inside working trains all the time, and a dead unit gets coupled in whichever way is convenient. But a dead unit is the exception, not the rule. On most trains, that backwards machine is loaded, hot, and doing work. The third is the most creative one, something about cooling or exhaust or airflow or keeping the crew out of the smoke. That was a real concern in the age of steam, and we will get there, because it produced one of the strangest chapters in this whole story. On a modern diesel, it is meaningless. The radiators do not care which way they are pointed. The engine has no idea it is traveling backwards. So if none of those explanations hold, what does? Start with the machine. A modern freight locomotive is not really a diesel machine at all, not in the way a truck is. The diesel engine inside it does exactly one job. It turns a generator. The generator makes electricity, the electricity goes to motors mounted down in the trucks, and those motors turn the wheels. Nothing in that chain has a preferred direction. An electric motor spins whichever way you send current through it, and it produces the same torque either way. There is a handle in the cab called the reverser. 3 positions: forward, neutral, reverse. It is removable, and if it is not in the stand, the locomotive will not move for anybody. It is about as close as a locomotive gets to having a key. Move that handle and the machine will happily haul 10,000 tons in the other direction with no loss of power and no complaint from anything mechanical. That alone would be a curiosity. What turns it into an operating strategy is a piece of technology that predates the diesel locomotive by decades. In the mid-1890s, an engineer named Frank Sprague was working on the elevated railways of Chicago, and he solved a problem that had nothing to do with freight. He wanted a way for one operator to control the motors in every car of a train at once, from a single position, using wires running the length of the train. He got it working. The idea spread through electric rapid transit systems worldwide, because it meant a train could be driven from either end and never had to be turned around at all. Locomotive builders picked the idea up in the decades that followed, and by the time diesels started taking work away from steam, it was standard. Today, it goes by an unglamorous name: multiple unit control. Every locomotive carries a heavy jumper cable and a bank of air hoses at each end. Couple 2 units together, plug them in, and one crew in one cab commands all of them. The early years of that were messier than you might guess. Some of the first streamlined cab units left the factory with no control connections in the nose at all, only at the rear, which meant 2 of them could be joined back to back but not nose to nose. Railroads ordered them in sets that alternated cab, no cab, no cab, cab, and those sets ran as a block for years. The back-to-back locomotive is older than most people assume. Here is the elegant part, and it is the detail that makes the whole backwards question finally click. That control cable carries a wire that means forward and a wire that means reverse. Now think about what happens when you turn one locomotive around in the middle of the group. Its front is now pointing at the back of the train. If it simply obeyed the command, it would try to drive the opposite way from everything else, and the couplers would take the argument personally. So the wiring solves it before it can happen. Inside each locomotive, that pair of wires is deliberately crossed at one end. When a unit sits in the group facing backwards, the forward command arrives on what is, for that machine, the reverse wire. It reads the signal in its own frame of reference, and it does the right thing. Turn a locomotive around, and it corrects for its own orientation, automatically, with no switch to throw and nothing for the engineer to remember. The machine, in other words, does not care. It was designed from the beginning not to care, which raises the real question. If direction does not matter, why bother turning anything at all? Why not just point them all the same way and forget it? For that answer, we have to go back to the era when direction mattered enormously. A steam locomotive could technically run backwards. It had a reverser, and yard engines spent their whole lives shuffling in both directions. But running a road engine backwards for any distance was miserable and often unsafe. The cab sat behind the boiler, which meant that going forward, the crew had a long black cylinder in front of them, and going backwards, they had a coal tender in front of them instead, blocking the view entirely. Many engines ran slower in reverse by design. The cab had a roof and a rear wall arranged for one direction of travel, so backing into weather meant taking the weather directly, and on a long run, the crew would be craning around a tender for hours. So steam locomotives got turned, constantly. That single requirement shaped the physical layout of the American railroad more than almost anything else. Every division point had machinery for it. The most familiar was the turntable, a steel bridge set in a circular pit, with the locomotive rolled onto it and rotated to face wherever it was needed next. It was compact, which mattered in a crowded terminal, and it fed a roundhouse, that fan of stalls arranged around the pit like spokes, each one with a vent in the roof for the smoke. Where there was room, railroads built a WIE instead, 3 legs of track in a triangle. Pull in on one leg, back onto the second, come forward on the third, and the machine emerges facing the other way. A railroad version of a 3-point turn. Cheaper than a turntable to build, but it swallows land. And where there was serious room and serious traffic, there were balloon loops, great curving tracks that let an entire train swing around in one continuous move without uncoupling anything. Think about the labor buried in all of that. Hostlers whose job was moving engines between the ash pit and the coal dock and the table, machinery to keep aligned and greased, pits to drain. Track to maintain that carried no revenue whatsoever, because a turntable does not move freight. It only rotates the thing that does. None of it was optional. It was the cost of running machines that only worked properly in one direction. Then the diesels arrived, and within about 15 years, the entire logic underneath that infrastructure evaporated. Here's where the story turns, because what happened next was not an addition. It was a subtraction. And it is the actual answer to the question we started with. A railroad that no longer needs to turn its locomotives is a railroad carrying an enormous amount of expensive dead weight. Turntables need maintenance, and a neglected one is a hazard. Roundhouses need roofs and heat and property tax. Ys occupy acres of ground in places where land had become worth something, and every switch in them is a component to inspect, lubricate, and eventually replace. So the railroads did the obvious thing. They started taking it out. Roundhouses came down through the 60s and 70s, replaced by straight-through service buildings that were cheaper to run and better suited to machines that no longer needed to be pointed anywhere in particular. Turntable pits were filled in, Ys were lifted, the switches salvaged, the land sold or paved. A few survived because a junction happened to need the geometry anyway, or because a tourist operation eventually inherited them. Most did not. And that is the thing worth sitting with. The reason you see a backwards locomotive today is not a decision somebody made about locomotives. It is the shadow of a decision somebody made about real estate 60 years ago in a place that is probably a parking lot now. Because once the turning equipment is gone, it does not come back. And a railroad still occasionally needs a train to go the other way. So the consist became its own turntable. Put one unit facing east and one facing west. Couple them back to back, and you have built a machine that can lead in either direction without ever being rotated. The crew reaches the end of the run, cuts away from the cars, walks the length of the power, climbs into the other cab, and now the group is facing the way they came. 10 minutes of walking instead of an hour of switching that the railroad no longer has the track to perform. It is worth being precise about what turning a set of locomotives actually costs when the option still exists, because the numbers explain why nobody chooses it. A Y move is not one movement. It is at least 3, each one requiring a switch to be lined and relined, usually by hand, often in the dark, sometimes in weather that makes handling steel unpleasant. Every reverse movement on a main track needs permission from a dispatcher who is managing other trains through the same territory and would rather not stop them. The locomotives occupy the main line while they do it, which means anything behind them waits. Air brake requirements have to be satisfied when the power comes back together. The crew is on the clock through all of it, and federal law puts a hard ceiling on how many hours they can work before they must stop wherever they happen to be standing. Now multiply that by hundreds of trains a day across a continent. Against all that, the cost of pointing one locomotive backwards is precisely 0. It burns no extra fuel. It pulls no less. It wears no faster. The only thing it costs is the mild strangeness of the sight, and railroads have never once cared how a train looks. That is the core of it, but the arrangement earns its keep in specific situations that are worth understanding because they are where the practice really came from. Think about a local freight, the kind that leaves a yard in the morning, works a series of industries out along a branch, and returns that evening. It goes out, it has to come back. The far end of that branch is a set of rusty stub tracks behind a grain elevator, and there is no Y, no loop, and nothing that could turn a locomotive if you offered to pay for it. So the crew takes power that faces both ways, works out with one unit leading, and works home with the other. The whole job depends on it. The same applies to a work train laying rail on a stretch of track, to a ballast train that has to return to the quarry, to a switching operation shoving cars into a plant and pulling them back out. Anywhere a movement is out and back rather than through, orientation stops being cosmetic and becomes the thing that lets the job exist. There is one more piece to this that is easy to miss from the outside, and it involves language rather than machinery. Look closely at the corner of any locomotive frame and you will find a small painted letter F. It marks the front, not because the machine cares, but because everybody working around it has to agree, absolutely and without hesitation, on what forward means. When a conductor on the ground tells an engineer to come ahead 3 cars, both of them need the same definition of ahead. When a switch crew is shoving a cut of cars into a track in the dark with nothing but a radio between them, ambiguity about direction is not a small problem. It is how people get killed. That letter exists so that a movement can be described the same way by everyone involved, no matter which way the machine happens to be sitting. If you are enjoying this one, subscribe. We dig into railroad engineering and locomotive history every week. That agreement about direction is enforced by rules, and the rules are strict. When a train is being shoved rather than pulled, federal regulations require point protection, meaning a qualified crew member has to visually determine that the track ahead is clear before the movement proceeds. There has to be a job briefing beforehand covering how they will communicate and how that protection will be provided. The person watching the point is not permitted to do anything else during the move. Those requirements are the practical reason nobody simply backs a freight train 100 miles. Reverse is not a mode of travel on a main line. It is a controlled, deliberate, heavily supervised exception, which is exactly why railroads would rather arrange the power so they never need it. Now, having established all of that, here is the twist. Some railroads looked at the same problem and came to the opposite conclusion. They decided that facing backwards should be the normal way to run. Early road locomotives with the cab set behind a long hood inherited a habit from steam. The view from the cab was similar to what an engineer had spent a career looking at, a long shape stretching out ahead, and that shape was a great deal of steel between the crew and whatever might be sitting on a grade crossing. Several early builders designated the long hood as the front from the factory. Most railroads eventually abandoned that. The visibility advantage of a low nose was too obvious to ignore, and by the 1970s, almost everyone was ordering locomotives that ran with the short end forward. Two railroads refused. Both operated in the southeastern United States, and both kept ordering locomotives with tall hoods at both ends, set up to run long hood forward right up until they merged with each other in the early 1980s. Their reasoning had two parts. The first was crew protection. In a grade crossing collision, the length of the hood was mass between an engine crew and the impact, and the practice was maintained in agreement with the operating unions. The second part is the one that connects directly back to everything we have been talking about. A locomotive built tall at both ends, with a control stand facing each way, can lead in either direction with the engineer sitting on his normal side, which means the railroad never has to turn it. One of these carriers had its diesels equipped with dual controls from the very first units it bought in the mid-1950s, and the stated goal was eliminating the expense and delay of turning locomotives on turntables and Ys at terminals. They were solving the identical problem. They just solved it inside a single locomotive instead of by pairing two. The crews, by most accounts, never warmed to it. Running long hood forward means looking down the side of a machine rather than over the front of it, out of a window, past a wall of steel for an entire shift. When wide safety cabs arrived, with their broad forward windows and their whole layout built around one direction of travel, the practice became impractical and quietly ended. Passenger railroading solved the same puzzle a third way, and you can watch it happen every weekday morning in any commuter terminal. A commuter train usually keeps a locomotive at one end and a specially built car at the other, with a control cab in the front of it. Outbound, the locomotive pulls. Inbound, the engineer walks to the other end of the train, sits down in that cab car, and drives from there while the locomotive pushes from behind, responding to commands sent through the same train line wiring that lets freight units work together. Nothing gets turned, nothing gets uncoupled. The train reverses direction in the time it takes one person to walk its length. This matters more than it sounds, because most big city terminals are stub-ended. The tracks simply stop at a wall. There is no loop, no Y, no way out except the way you came in, and platform time is measured in minutes because another train is already waiting for the space. Freight railroads use a version of the same trick when they place locomotives at the rear or middle of a long train and control them by radio from the head end. In that role, orientation is not even a conversation. Those units are frequently coupled in whichever way they were sitting when the crew found them, because nobody will ever ride in them and nothing about their performance changes. Which brings us back around to the human side of it, the part that does not show up in any rulebook. Ask an engineer about running a locomotive backwards and you will not hear about physics. You will hear about the hood, about leaning out a side window in the rain to see a signal, about judging the distance to a coupling when the thing you are trying to hit is behind a wall of steel and the only information you have is a voice on a radio counting down car lengths. 15, 10, 5. That's good. You will hear about the strange courtesy of the second cab. A locomotive facing backwards has a full control stand nobody is using, seats nobody is sitting in, and windows that look out at the road unspooling away behind the train. On a long run, it is the quietest room on the property. And you will hear about the arithmetic of the tie-up. A crew that reaches the end of a run with power facing both ways knows they can change ends and go home. A crew that reaches the same point with everything pointed the same way is looking at a switching move, a dispatcher call, and time they do not have. So the next time you are stopped at a crossing and the second locomotive slides past facing the wrong way, understand what you are actually looking at. You are not seeing an error. You are seeing a railroad that decided long before anyone in that cab was born that it would rather not own a turntable. You are seeing the answer to a question about buildings that were demolished, land that was sold, and switches that were pulled up and hauled away for scrap. You are seeing a piece of infrastructure that no longer exists, preserved in the shape of the train that replaced it. Every consist is a small statement about where that train has been and where it is expected to go. All units pointing one way usually means a route with somewhere to turn at the far end, or a train that will never need to come back the way it came. Units facing each other means somebody expects that power to lead in both directions before the week is out. The locomotives themselves are indifferent. They always were. The electricity does not know which way the nose is pointed, and the steel does not have a preference. That indifference is the whole reason the modern railroad can run the way it does, with far less track and far fewer buildings than the one that came before it. Somewhere out there, in a town where the roundhouse became a warehouse and the turntable pit is under a parking lot, a train is heading home tonight with its second locomotive facing backwards. Nobody who built that arrangement is still alive. The train works anyway. That is the point.